In this video, we continue the topic of improper integrals. In the previous video, we talked about the improper integrals that were from a number. So the limits of the integral, the lower limit was a number, the upper limit was plus infinity. But in this video, we talk about the proper integrals that they are from minus infinity up to a given number. Let me call that given number b. And we want to do or define the integral from minus infinity to a given number b of f of x dx. The definition is similar, kind of similar to the definition that we had from a number to plus infinity when the limits of the integral was from a number to plus infinity. Here we replace minus infinity by a and let a tend to minus infinity. So b in this case, b is a given fixed number, and we are calculating the definite integral from minus infinity to b. We replace minus infinity by a letter a, and then let a tend to minus infinity. Let's do some examples to clarify this. I want to evaluate the integral from minus infinity to 2 of e to the power of 2x dx. And we should choose the correct answer, A. So which one is correct? It's convergent, and it converges to a finite number that I need to type in here, or it diverges. So which one is correct? So this, in fact, which one is correct? Okay, uh, this integral, by definition, the integral from minus infinity to 2 of e to the power of 2x dx, by definition is the limit as a tends to minus infinity of the integral from a to 2 of e to the power of 2x dx. And so let's keep the limit here. Antiderivative of e to the power of 2x, as we know from before, it's e to the power of 2x over 2. In general, the antiderivative of e to the power of kx is e to the power of kx over k. And then we need to evaluate at the limits of the integral. So the limit as a tends to minus infinity. The evaluation of that function at the upper limit, which is e to the power of 2 times 2, 4 over 2, minus the evaluation of this function at the lower limit of the integral, e to the power of, replace x by a, 2a over 2. Now let's apply the limits. Limit as a tends to minus infinity. When a tends to minus infinity, 2a becomes minus infinity. 2 times minus infinity is minus infinity. And as we discussed this in the previous meeting, it was a reminder of Calc 1, e to the power of minus infinity is 0. So therefore, when a tends to minus infinity, e to the power of 2a over 2 is gonna be just 0. So this is equal to 0. So the only thing remaining is e to the 4 over 2, which is a finite number. Therefore, the integral is convergent. It converges, and the value as a finite number is e to the 4 over 2. Let's do another example. The integral from minus infinity to minus 5 of 1 over x squared dx. And I want to know which one is correct. A, it converges, the integral, in fact, converges to this finite value, or B, it diverges. Okay, try to do this on your own and choose the correct answer. And you know how to deal with the integral of 1 over x squared, something you have seen in Calc 1. Remember that 1 over x squared is the same as x to the power of minus 2. Okay, so this integral, by definition, is equal to what? The limit as a tends to minus infinity, the integral from a to minus 5 of 1 over x squared dx. So that's going to be the limit as a tends to minus infinity. Antiderivative of 1 over x squared is, as we have seen, we have had this before, even you have seen this in Calc 1, is minus 1 over x. And you need to evaluate that at the endpoints or the limits of the integral and do the subtraction. So this equals the limits as a tends to minus infinity. The evaluation of this from minus 1 over x at minus 5 is minus 1 over minus 5 minus the evaluation of this at 1 minus 1 over a. Now look at the parentheses which contains a. I have 1 over a, and a tends to minus infinity. As you might remember from Calc 1, 1 divided by plus or minus infinity is going to be 0. So the second parentheses is just equal to 0. Or when a tends to minus infinity, 1 over a tends to 0. So the only thing remaining here is going to be minus 1/5, which is 1/5. So the value of this integral is a finite number, and that's 1/5. So we choose A. So in both of these two examples that we have done so far, the integral was a convergence integral. Let's do another example. Again, I suggest that you try this on your own and then watch my solution. The integral from minus infinity to minus 27 of 1 over cube root of x dx. So which one is correct? A, it converges to a finite number. And if this happens, I need to type in that finite number, or it diverges. The integral diverges. Let's see which one happens. So we use the definition of this improper integral, the limit as a tends to minus infinity of the integral from a to minus 27 of 1 over cube root of x dx. Remember that cube root of x is what? Is x to the power of 1/3, right? Cube root of x is x to the power of 1/3. What about 1 over x to the power of 1/3? It is x to the power of negative 1/3. So this is x to the power of negative 1/3. And I can use the power rule for the integrals, right? So before applying the limit, antiderivative of x to the minus 1/3 is x to the power of minus 1/3 plus 1, which is x to the power of 2/3 divided by 2/3. Dividing by 2/3 is the same as multiplying by 3/2. So let me just write 3/2 here. And this function should be evaluated at the limits of the integral, and then we do the subtraction. Okay, so the limits as a tends to minus infinity. This parentheses at minus 27 is, or this function at minus 20, when x is minus 27 is 3/2 times minus 27 to the power of 2/3 minus the same function evaluated at a 3/2 a to the power of 2/3. Let's first discuss the parentheses which contains a. And when a tends to minus infinity, what happens? So let me discuss that here. I'll come back and complete the solution. When we have the limit as a tends to minus infinity of a to the power of 2/3. I hope you remember this kind of problems in Calc 1 that when the variable tended to infinity or minus infinity. There are different ways to discuss this. One way is I can think of a to the power of 2/3 as a squared raised to the power of 1/3. When a tends to minus infinity squared is plus infinity. and plus infinity raised to a positive power, to power of 1/3, is still infinity. So infinity raised to a positive power is still infinity. So for this reason, this part is infinity or tends to infinity, which means that we are dealing with a divergent integral because we have infinity involved here. It's not 1 over infinity that makes it 0 or a number divided by infinity that makes it 0. It's infinity there. And so this integral uh, is not a convergent integral. It is divergent. Or to be more accurate, whatever the number, the first parenthesis is, this 3/2 times infinity is infinity, and there is a negative here, makes it minus infinity. Since it's minus infinity, this integral is a divergent integral. Okay, let's go to the next example. Again, I suggest that you do this on your own before watching my solution. The integral from minus infinity to 2 of 12 e to the power of minus 3x dx. So which one is correct? A, it converges to this finite value, or it diverges. So by definition, this integral equals the limit as a tends to minus infinity, the integral from a to 2 of 12 e to the power of minus 3x dx. For now, let's keep the limit here and calculate the integral. 12 is a constant, comes out. Antiderivative of e to the power of minus 3x is e to the power of minus 3x over minus 3. And this should be evaluated at the limits of the integral. And then we do the subtraction. Before that, 12 over minus 3 is minus 4. So let me simplify this as minus 4. So this equals the limit as a tends to minus infinity. The evaluation of that parentheses or that function inside the parentheses at 2 gives me minus 4 e to the power of minus 3 times 2, which is minus 6. Minus the evaluation of that parentheses at a minus 4 e to the power of minus 3a. So we just replace x by a. So first, let's see what happens to the parentheses which contains a. Be careful, a tends to minus infinity. If a tends to minus infinity, minus 3 times minus infinity will be plus infinity. So a tends to minus infinity. So minus 3 times a becomes plus infinity. And e to the power of infinity is infinity. So since a tends to minus infinity, and in that exponent, minus 3 is multiplied by minus infinity, the exponent of e is plus infinity, and e to the power of plus infinity is infinity. So that's why here, this part tends to plus infinity. And minus minus 4 plus 4 times infinity is infinity. The first parenthesis is a number. A number, when it's added to infinity or it is subtracted from the infinity, it doesn't affect the infinity. So this is a plus infinity answer, which means that it's a divergent integral. So the integral diverges. It is because it's not, the value is not a finite number.